Number 8. You have a system of 2 equations and 2 variables. One of them is nonlinear. Well, the bottom one's linear, but the top one, the x multiplying the y, that is nonlinear. So, what I'm going to do is take the lower equation and solve for x. Now I'm going to replace x in that upper equation. Okay, here we are. Where I used to have x, I can write this, 3/2 y plus 1. So now I have an equation in just one variable. I can solve for that variable. Well, nicely. All these great problems they give us in this book. The numbers work out nicely. The 2's cancel. I get 3y plus 2. The 2 multiplies the 1 plus y equals 36. That goes down to, oops. This is, there's the mistake right there. This is all being multiplied by a y right there. I forgot to copy down that y. So, we get to here. Now the y multiplies through this set of parentheses. I get 3y squared plus 2y plus y equals 36. Okay. So that's 3y squared plus 3y equals 36. I see everything divides by 3. Let's do that. Divide each side by 3. Get smaller numbers to work with. And I arrive there. It's a quadratic equation, of course. Let me subtract 12 from each side. See that little trick there? That's a quick way to write it. And let me go ahead and factor. It's y plus 4 times y minus 3 equals 0. We're fortunate again that it factors. Which tells me that y is equal to -4 or +3. All right, so I see there are going to be 2 points of intersection, right? 2 ordered pairs. I've got 2 values for y. I have to find out which values of x correspond to each of them. So, for the first one, I'll take y equals -4. And I'll plug that into the bottom equation. So I get 2x plus 12 equals 2. 2x equals -10. X equals -5. We can do a quick check. I just used this equation, so let me plug these x and y values into the top equation. Let's see what I get. 2 times -5 times y equals -4 equals 36, hopefully. Well, this is 2, sorry, we made a little more here, plus y again, which is -4. All right, so here's how I have substituted into the left-hand side of that equation. This is supposed to equal 36. Let's see, 2 times -20 minus 4, so it's -40. Something's wrong. Something's wrong. It's +40, right? because negative times negative gives me positive 20. Okay, so that checks out. Let's figure out what the other winning combination is. That's when y is equal to 3. And in this case, I again used the bottom equation. All right, I replaced y with 3 in that lower equation. So I get 2x minus 6 equals 2, 2x equals 8, x equals 4. What the heck? I'm having a terrible day doing my calculations. That's a minus 9. Okay, so 2x equals 11. So x equals 11 halves, which looks bad. Usually they don't make you deal with a messy fraction like that. Let's do the check. Maybe we made another mistake. Check. Back in the first equation, I'll plug this in. 2 times x times y plus y. And this is supposed to work out to be 36. 2's cancel out. I get 11 times 3 plus 3. So I get 33 plus 3, which is 36. So that works. So my final solution looks like this. -5, -4, right? That's this combination. And then, I guess I'll have to go down here. X is 11 halves. Y is 3. All right, and there is your solution to problem number 8. And of course, you can always solve it graphically. You could just graph these functions on your device and so you can get the points of intersection, however you like to do it. So for homework, on page 577, (7 through 13 odd).